Now we're going to look at finding limits of a piecewise function without looking at the graph. So here's our piecewise function. Okay. So we've got f of x equals 2x plus 1 when x is greater than or equal to 1, and x squared plus 3 when x is less than 1. And the key thing to think about here is the point at which it's changing that we're going to have to be careful is when a is equal to 1. Otherwise, since these are just polynomials, we'll plug it into where you would evaluate the function. So here, when we want to find the limit as x goes to -6, well, -6 is less than 1, so we'll plug it in to this part of the function, x squared plus 3, which -6 squared is 36 plus 3 is 39. So that's going to be the left-handed limit, the right-handed limit, the limit, and the function value. Because for that part of the graph, it looks like a parabola. That is, it would just be nice and smooth. Now, I said x equals 1 is where we'll have to be careful. So for the left-handed limit, that means we're less than 1. So we're going to use the less than 1 and plug it in there. So we'd have 1 squared, which is 1, plus 3. Our left-handed limit is 4. For the right-handed limit, we want to go where we're greater than 1. So we plug 1 in up here, which would be 2 plus 1 would be 3. Now, since the left-handed and the right-handed limit are not equal, our limit does not exist. And our function value is where the equal to part is. So since the top line is greater than or equal to, we know we would plug 1 in there and get 3. Okay, and then 7's not a place where the function changes or anything. So we're going to plug it into the part where x is greater than or equal to 1, since 7 is greater than 1. So we'll plug 7 in and we'll get 15. So that's the left-handed limit, the right-handed limit, the limit, and the function value there.